All right, we're continuing. Question number 8. Preparing for test for Unit 6. All right, let's read it. At every point of the curve, y equals f of x, the slope of the curve is given that. Remember, the derivative means slope. That. It says find an equation for y equals f of x if it passes through this point. So I'm given the derivative. I'm asked to find the function. How would I do that? Is I would integrate. So I'm integrating 2x cubed times the square root of x to the fourth plus 9. Now the question is, how would I integrate that? A couple things come to mind. One thing comes to mind. This looks like an anti-hook rule, which means what's under the square root sign, if I take the derivative of that, does it equal the hook that's in front? So the derivative of this is 4x cubed, but what's in front is 2x cubed. But I can manipulate the constant in front. So this is how I'm going to write it. I'm still going to integrate. Recognize the hook. So the derivative of x to the fourth plus 9 is 4x cubed plus 0, or 4x cubed. That's the hook in front. I'm going to write this with a fractional exponent. And then the last step is I need a fraction that keeps these equivalent. And the fraction in front that keeps it the same is what was it before and what did it become. So what it was over what it became. And you could write that as 1/2, but unnecessary. Now I can integrate. So the hook part, you can pretend it's not there because it's embedded. And then you can do the anti-power rule. So 2 over 4 is going to stay in front. The rule is you add 1 to the exponent. So 1 over 2 plus 1 is 3 over 2. Divide by that, or times the reciprocal. So we also have a constant with that, because it's an indefinite integral. Now it might be helpful here to simplify it a bit, because then we have a number to plug in to see what c equals. So if I simplify this just a little bit, it's going to be 4 over 12. Well, I don't like that. So 4 divided by 4, it's going to be 1/3. I like that better. X to the fourth plus 9 to the 3/2 plus the constant. Now we're going to use this, 0 and 1. This tells me that when the x coordinate is 0, the y coordinate's 1, and I can solve for c. So let me do that here on the side. So the y coordinate's 1. The x coordinate is 0. And now let's see if we can solve for c. So 0 plus 9 is 9. A fractional exponent. The square root of 9 is 3. And 3 cubed is 27. So again, the denominator is the root. So square root of 9 is 3. And 3 to the exponent 3 is 27. This is 27 divided by 3, or 1/3 of 27, which is 9. And then subtract, and c is equal to -8. So I'm just going to put the answer here all together. I'll put a line like this that shows this is all together. What would your final answer be? It would be y equals 1/3 x to the fourth plus 9 to the fractional exponent 3 over 2. And then we found the candy. And we just said the constant is -8. Number 9. Find the value of p for which this function is continuous. So this is piecewise. Notice at what x value it's broken into 2 pieces. If this is continuous, when I plug 2 into the top and plug 2 into the bottom, it would give you the same answer. So I'm going to write down 4 times p But I'm going to put in the number 2 for x, subtract 6. I'm going to make it equal to the bottom piece, which is 2p minus, and again, where there's an x, I'm going to plug in 2. And then I'm going to solve that equation. So if I take 2 on the top and 2 on the bottom, if I substitute them in, they have to give you the same answer. That way there's no jump or break or hole or anything like that involved. That means it's just one continuous piece, as if when you plug in 2, it gives you the same answer. So here it is. Could you solve for p? So 4 times 2 is 8p, subtract 6. There's p, subtract 4. Distribute. Combine like terms, subtract 2p, so 8 subtract 2 gives you positive 6p, add 6, and then divide. That's a great answer. You do not need to simplify it. Don't even practice simplifying it. The answer is negative 2 over 6. All right, turn the page. Number 10, it says use your calculator, so I'm going to have to do that. It says let the function equal this, and it says find f at 2 and the derivative of f at 2, and then integrate. So let's do a few things with our calculator. So first, if I said find f at 2, use your calculator. So I'm going to type in 2 times 2, subtract 4, ln, the ln button. Do you see e to the x? It's the blue. So press blue button and e to the x, that's ln. And then 2. So I get the answer 1.227. Then it says take the derivative at 2. So I am going to take the derivative of this. So let's do that first. So let's press menu. No, we're not going to press menu. I'm going to press this button right beside the 9 again. So where's the derivative one? So I'm going to take the derivative of 2x, subtract 4 ln x. Yeah. Now I'm going to try something I don't normally do, but I think I can do this in one step. I'm going to show you a button. Do you see the equal sign? I want you to press Control and equal, and I want you to see there's a vertical line in that bunch. And what that means, that vertical line means that you're going to evaluate at a certain number. So that vertical line means I can then, it's like an at symbol, like at what value. So at when x equals 2, I'm going to see if that works. So in other words, I'm taking the derivative and telling the calculator right away to evaluate the derivative at x equals 2. Oh, it didn't like it. See if I can. Let's try this. So I'm going to go back up. I'm going to erase what I just did. Just going to do the derivative so you can see what the derivative looks like. Let me see if I can do this. Take the derivative. I'm going to press the same button. Perfect. All right. Oh, and it gave me the answer anyways in the beginning. So when you plug in 2 into that, the answer was 0. It did give me a caution sign, so it made me kind of nervous whether that actually worked or not. But if I go back up here, the answer was actually 0, which made me nervous to think if it did do it correctly. It did actually do it correctly. But then it gave me a caution to make sure that I did it correctly. So that might be a new symbol for you, that vertical line, or then you can evaluate at a number really quickly. All right, so regardless, the derivative at 2 is equal to 0. Then it says, can you integrate from 2 to 4 and get an answer? So again, I'm going to use my calculator. I'm going to press that button beside the 9. And now I'm going to go to the integration. And again, I'm going from 2 to 4. And I'm typing in 2x subtract 4 ln x. And then I make sure I finish it off. I'm taking the derivative with respect to x. Oop, go back here. So the exact answer is this. The approximate answer is 3.364. Both answers would be fine on the test. Here's something we haven't done much in class together. This is one where you learned it on your own over Thanksgiving. Let's go back and make sure we understand what average value and what you're doing. If I want to find the average value over an interval, it means you're going to integrate, and the interval gives you the bounds of the integration to find the average value. So that goes from 1 to 3. You're going to integrate this function. And then you're going to divide by the difference between the bounds. So in other words, 3 take away 1. So again, average value means you're going to integrate. So you're going to find the area and then divide to find the average value. So we're integrating. Where do I find the bounds? From the interval. And I'm just integrating the equation given using that interval. And then I'm dividing it by the difference of the bounds. So in this case, 3 take away 1. That's it. So let's do this work quickly together. So I'm integrating from 1 to 3, 4 x minus 1 to the 3. I notice that 3 take away 1 is 2. I can also, instead of going divided by 2, I can also just write down 1/2 in front. And then to make my life even simpler, notice this 4, one of the properties of integration is that constant can be written in front. So I can combine together 1/2 times 4 together, and that makes 2. When I look to see how I would integrate this, don't forget the dx, I'm thinking, is this an anti-hook problem? Now, when I take the derivative of the base for the hook, the derivative of x subtract 1, well, the derivative of x is just 1. So really, the invisible 1 is actually there. That hook, in some sense, is unnecessary. It's just positive 1. So it's ready to integrate. So I'm going to start with 2. How do I integrate this? Is I add 1 to the exponent. So that becomes 4. And then I divide it by that exponent, which is 4. And then I'm integrating from 1 to 3. That's it. I added 1 and divided. The 2 is in front of all that. When I finish it, I understand that I'm going to plug in the top number first. Subtract, plug in the bottom number second. Done. That is the average value of that function from 1 to 3. So in other words, on average, what's the y coordinate? On average, when you plug in 1 all the way to 3, on average, what is the output? The average y value. And that gives you the answer. If you don't have to do this, but if you notice, this is just going to be 1 take away 1, which is 0. So if you did simplify it, which I don't want you to do, but if you did, if it was multiple choice, it'd be 2 to the exponent 4, which is 16. 2 times 16 is 32 divided by 4. This whole answer would be 8. So on average, from when you plug in 1 all the way to 3, what's the average y-coordinate you're going to get? And the answer is 8 using calculus. All right, number 12. Find the volume of the region bounded by these two equations, x cubed subtract 2x, x equals 2, and y equals 0. And it's revolved around the x-axis. So let's get a picture of this. So if I want to graph x cubed minus 2x, a good place to start are the x-intercepts. So I'm going to make it equal to 0 and find out where are the x-intercepts here. So I'm going to factor out a common factor, x. I have x squared minus 4. I recognize that x squared, why did I get x squared minus 4? X squared minus 2. Is that right? Yeah. So I recognize that I got x plus root 2 and x minus root 2. Let's see if that would help me at all. So I have 0, I have negative root 2, and I have positive root 2. I don't think I'm going to have to use the square roots because of the other bounds. So if I sketch this, I have 0, 0, and it says go to 2. So x equals 2 is right here. Y equals 0. That's the x-axis, so that's the other bound. So I have 2. I have 0. And then I have this function. If I want, I could plug in positive 1 and get 1 take away 2, which is negative 1. So I know there's a part of the equation that might be interesting. Root 2 is somewhere here in the negative root 2. But you can get a sense of what it looks like there. Right there, root 2 is where it crosses. On this side, it would do something else, but I don't care about the left side, and negative root 2 would also cross in terms of what it would look like. But this is the area, and we're revolving it around the x-axis. So I'm just going to treat it as two different disks that I'm revolving it around. So the first disk, in terms of what's happening, goes from 0 to root 2. I don't have a washer, so it's a simple template of pi, and it integrate from 0 to root 2, so I'm going to have to use the square root. And the radius is simply the equation. X cubed minus 2x. I'm going to square it, dx. And then I'm going to add, in fact, when I look at it, I don't think I even have to separate it this way. I could have just done the whole thing as 1. So this is treating it as two different areas. Though really, we're going all the way from 0 to 2 with that same function with no washer. This would give you the same answer. So let's just go integrate from 0 to 2. Pi r squared, where the function itself, x cubed minus 2x, represents the radius. And it's pi r squared dx. Let's just start right there. That's the setup. Use your calculator. So I'll type it in and then I'll show it to you. So it's pi integrating from 0 to 2, x cubed minus 2x squared, that pi r squared dx. And the approximate answer to that volume is 10.531. I do believe that if you did it two separately and added them up, you'd get the same answer. You can test me on that one and try it. But anyways, I think you write it just as 1 from 0 to 2. So you have the part below and the part above. Just treat it as one thing in terms of the radius and revolving it around, pi r squared, and you get your answer. 13. Suppose the function is a differentiable function whose graph contains the point 0,8, and you're integrating from 0 to 5, f at x dx equals 4, and it says find f at 5. So this is a starting value problem again. So what they're saying is when x equals 0, that's not 0, when x equals 0, what does y equal? 8. That's your starting value, 8. Then you're going to integrate. Where does x start with? 0. And what we're interested in is f at 5. So from 0 to 5. So in other words, you start at 8. You integrate from 0 to 5. And really, I think this should be the derivative of the function. So 0 to 5, the derivative equals that. I think that's a typo. But when you look at the problem, the starting value is 8. When you go from 0 to 5, it increased by 4. And so what's the end value? F at 5 then would equal 12. So I think I'm going to go back and make sure that's typo. That the derivative of f at x, when you integrate that. So when you integrate the derivative from 0 to 5, it shows it increases by 4. So we start at 8, it increases by 4, the end answer is 12. Number 14.